Hey everybody, Corey and Victoria here. We are the Professor's Du Bois, and today we're going to talk about molar mass in this video lecture.
Yep, molar mass, very important. We're going to use it a lot. So how do you calculate the molar mass, and what is a molar mass? So we talked about in the last video how the masses on the periodic table, if you have 1 mole of them, the masses on the periodic table are in AMU and in grams in 1 mole. So if you can add up the masses of each element in a compound, then you will have the molar mass, or the mass of 1 mole of that compound.
Got a little fly-by-fly action in here.
Yeah, so, we do.
But
you saw that.
We're gonna keep going.
All right. So we want to know how many grams are in 1 mole of CH4.
Okay, so if you have your periodic table handy, and you should, you can look at the masses of each of the elements in this compound. So we have 1 carbon, and the mass from the periodic table is 12.011 grams, and we have 4 hydrogens here. So we're going to take the mass of hydrogen, multiply it by 4, and then we're just going to sum those two numbers, the 12.011 and the 4.032. That gives us 16.043. So what that means is 1 mole of CH4 is equal to 16.043 grams. This is an equality.
It is.
1 mole equal.
What's that mean?
So we can use this as a factor. That's where we're going with this.
Conversion factor. Now, if you didn't know where the 4 hydrogens came from, it's from this little number here. So the subscripts of each tell you how many of the atom there are. So the 1 we just leave out. So there's 1 carbon and 4 hydrogens. Since we have a conversion factor now, we can use it to convert between whichever units are in that conversion factor. So in this case, we talked about having grams and moles. Grams in 1 mole, that means that we can go from grams to moles and moles to grams, just like it's shown here. You might see molar mass written as different words. So it's molecular weight, gram formula mass, formula weight, and there's probably a few others.
Atomic weight, maybe?
Atomic weight probably would be the AMU.
Yeah, you're right.
But for the 1 mole, there's a lot of different things. So remember this, we've that 16.04 grams per mole for CH4. We're going to use that later.
So here's an example. So we want to calculate the molar mass, and this one's especially tricky because we have the parentheses in here. And what this means, you see the parentheses around the NO3. That means that little 2, that subscript 2, applies to everything inside those parentheses. So what we really have here are 2 NO3s. And if we look at it this way, that means we have 2 nitrogens and 6 oxygens. So when we sum these masses up, we have 1 calcium with a molar mass of 40.078. We've got 2 nitrogens at 14.007 each. So we multiply that by 2. There's 2 nitrogens. And then we take the mass for oxygen from the periodic table, multiply by 6. When we sum these up, we get 164.086. That's the number of grams in 1 mole of calcium nitrate.
Yep. So that means that we have a derived unit. We have something that has more than 1 unit. That means we can use it as a conversion factor. So let's try. So this is a mass to moles conversion using molar mass. So anytime you have grams of something and you have the formula, you have the molar mass because you can use your periodic table. So in this question, how many moles are in 346 grams of CH4? This 16.043, we calculated this before as the molar mass of CH4. So Professor Corey likes to put the first number over 1, and that just shows that this grams is in the numerator. If grams is in the numerator and we don't want it, we have to put grams in the denominator. So when you have your conversion factor, you can put grams or moles on top, but we want to put grams on the bottom and moles on the top because we want to be left with moles in the end, because that's what our question asked for, how many moles.
Excellent.
So 346 is in the numerator, so that is like we multiply through the numerators and we divide by the denominators.
So there's a lot of factors to convert to and from moles, and we talked about using Avogadro's number in our previous video lecture. We can use Avogadro's number. We can use the molar mass from the periodic table, and there's going to be more derived units, and you look for that word mole in your derived unit, and you can get to moles.
Yes, stay tuned for a lot more conversion factors to moles. All right, so this is an example. This is a two-stepper. Okay, we want to know how many molecules. That tells me I'm going to probably have to use Avogadro's number. Anytime you need to calculate the number of atoms or number of molecules, there's a little pro tip there.
Yeah.
But we're starting with grams, and I can't go directly from grams to molecules, but I can go from grams to moles, and then I can go from moles to molecules. So that's what we're going to do. We're going to start with what we know that's not the factor, and that is just what was given, put the 0.035 grams. We know we need to cancel grams, so we're going to put grams in the denominator so we can cancel grams. Once we have grams, or once we have moles, we can cancel moles and go directly to molecules using Avogadro's number. Whatever's not canceled is what you are going to end up with in your answer.
It's pretty interesting. That's a pretty small mass, 0.035, and that's a rather large number of molecules.
A lot of molecules. Yep. They're so small. All right, so we want you to pause the video and practice these. You should be able to do all of these now. What is the gram formula mass? That's the molar mass. That's the same thing of this compound. And then from that, calculate your grams from moles. And then you have the two-stepper in the last question. So pause the video and try these. Here's your answers.
All right.
All right.
Hopefully
you did well. And that does it for this video. Thanks for watching.
Stay tuned for more video lectures.
Yeah, we'll continue on with more information about the mole and more converting with the next video. Thanks for watching. Bye-bye.